Okay, and we are live. Welcome to our final On-Ed Student Chat for the 2017 and 2018 school year. I want to thank everyone for joining us on panel today and welcome all of you who are taking part on Twitter or on YouTube Live. On-Ed Student Chat is a student-led Twitter chat that connects K-12 students across the province to discuss topics and questions related to character education, social justice, and citizenship. On-Ed Student Chat creates opportunities for students to network with others, gain new perspectives, build relationships with new learning partners in a literacy-rich learning environment, experience social media as a powerful platform for learning, and establish a positive digital footprint. So thank you again for joining us. I'm now going to turn things over to Austin, who's going to offer our tech talk.
Okay, so if you're watching us on YouTube, you will notice there is a comment space to your right, and this is a great way for you to share your own thoughts and ideas and add your thinking to get involved in the conversation. Or you can watch the video from our website, which is onedSSchat.com, I'm pretty sure. And you can follow us on Twitter and use the hashtag OnEdStudentChat, which is again ONEDSSchat, to read thoughts, ideas, and questions shared by others. You can use the hashtag to add your thinking and get involved in the conversation. If you ask questions, we will bring them over to the panel, but please remember that the audience for this chat is K-12, so your questions and comments should be appropriate for all ages.
Great, thank you, Austin. I'm now just going to take a second to introduce everybody. If you want to give a quick wave, we have Austin Gagne joining us here. Austin, do you want to say hello? And we have Rylin from Hawick Public School. And so these are two of our student leads who are joining us today. We have another student lead, Emiliana, will be popping in a little bit later. It's a very busy time of year. So unfortunately, the rest of our team is occupied writing tests and working on projects and doing lots of cool things. I do want to welcome Brock Baker is here as well, joining us as one of the teachers on the On-Ed Student Chat team. And now I want to introduce our special guests. We have two students from Rola Tibshirani's class in Ottawa. We have Aaron, if you want to give a wave. And Gustavo. Awesome. And then we have another special guest joining here today. Steve Floyd's joining us, and he's a high school computer science teacher. And he's also, I would say, an expert in the world of computational thinking, computer science, and coding, and does a lot of work in the province of Ontario. So he's joining the conversation today as well. If you want to.
Hi, everybody.
Awesome. All right, so we are going to go ahead and Rylin is going to go over some of our tweet and talk norms, and then we'll jump right into the questions. Rylin?
All right. So for our norms, we will have 20 minutes to discuss one or more of our questions today. We ask that you please be mindful because this chat is open to K-12 students. We have active participation from classes who are watching. All comments made during this chat should be positive and productive. Everyone is entitled to their own opinion. You may not agree with something someone has said, but we ask that when challenging an idea that you respectfully disagree with the idea and not the individual person.
Great, thank you, Rylin. So we are ready to get started today. Rylin, if you want to introduce the first question, we'll go ahead.
Okay, so our first question for today is, what skills are you learning when you code?
All right, who would like to tackle that question first? All right, go ahead. Yeah, Aaron, go ahead.
Okay, skills when we learn coding is typing, one thing that I kind of learned when I was coding, problem solving, creativity, and innovation and communication skills.
That's quite the list. Gustavo, do you have anything to add?
You learn how to do math. You learn how to do integers. You learn how to like calculate things easier because you're putting variables into equations. Like for example, if this is that, and then you're learning math in a lot of ways.
Absolutely. Aaron, you mentioned problem solving. Can you give an example of a problem maybe that you've solved?
Well, this is just an example. Say for instance, like people with Alzheimer's, right? During like nursing homes, stuff like that. Nurses don't really know when people get up, like people with Alzheimer's get up. So it's pretty unpredictable, but with like technology, like coding and stuff, so they can like, you can make like a sense, pressure plate. So if they step on the pressure plate, it'll send an alert to your phone or something, and it'll alert them that they've like stood up or like woke up.
That is an incredible example. Thank you. Austin or Rylan, did you want to share your thoughts?
Here, I'll go.
Yep, great.
First, I'd like to say that D. Stephen Floyd is on panel with us today, and I'm like freaking out a little bit.
I know.
Skills, this is my whole spiel that I use a lot. Leadership, because sometimes I find that if you're ahead of the code or you're behind, you can show the students where to go. Problem solving, because there's definitely problems with coding because you can put a block or something in the wrong spot. And then same thing with debugging, because you have to go through the code and make sure everything's running properly.
Steve, do you want to jump in?
Yeah, I was hoping I could ask a question of the students that are here.
Absolutely.
When we talk about the skills that are happening with coding, I'm just curious what your classrooms are like when your class is engaged in coding. Like, is it really quiet, or is there a lot of talking? Are students working on their own, or are they working in groups? Maybe we could learn what skills are being developed by talking about how the classroom's actually functioning. So what does your classroom look like when all the students are doing coding?
Rylan, do you want to answer that?
Yeah, our classroom, I guess it depends on the day. If we're focusing on a brand new something, like a brand new challenge, it'll be very talkative because everybody's trying to figure out what's going on, what they need to do to get the robot to do this. But if we're nearing the end and everyone's focusing and they're trying to get it done before a big competition, we're all super quiet and we're just 100% onto the code. Yeah.
Anyone else?
That's just like our high school classes too. Some days everybody's sharing and speaking and talking with each other, and then other times everybody's really, really focused trying to solve a problem because they know exactly what problem they need to solve, so they're really, really focused. But I'm wondering, is there a lot of teaching going on? Is it the teacher teaching the students, or a lot of the students teaching each other when you're doing coding?
A lot of the time for us, there's definitely some kids that are really high on the coding scale, and everyone they know what they're doing, and then there's some kids that don't so much know what they're doing, and then sometimes our teacher doesn't know what we're doing. So everybody's teaching each other in their own little way. Whether it's building the robot or coding, everyone has their own strengths and weaknesses, and then when you mix it together, it creates something awesome. That's
cool. Cool.
That was cool. Very well said, Rylan. I love the mix of awesome. It really is, right? Because in any situation, you have a variety of people, and they all come with different skill sets. And when you're open and put all that together, and I think you have to allow yourself to be vulnerable as well, right? Because especially if you're not in the know. And that's a very powerful experience. Brock's just shared something from Twitter here from @Miss Evoy Nakina Pub, and I always mess that up. Some of the skills that I think you're learning when you're coding is procedural order and problem solving. So that's from Kristen Evoy's class. I need to work on pronouncing her Twitter handle properly. Another comment on Twitter is that you're learning leadership and instructional skills. So that speaks to the conversation going on here. Gustavo or Aaron, did you want to answer Steve's question or speak to your space and how things work in your space?
So in our school, in innovation, in our school, we don't really learn coding. Instead, it's a club where you learn code and stuff. So in this club, we call Innovation Club. We learn 3D printing, coding, with microbits, Scratch, and Arduinos.
We collaborate to make projects that help other people in our community. For example, so I made a game. It's called Mining Simulator. Basically it's just for entertainment, but it was really tough to make. So I had to work hard, and I had to learn from my mistakes, and I had to repair some stuff and everything. So you learn from your mistakes, you collaborate with other people, you get help and everything, and then you succeed.
Cool, awesome.
That is awesome. Austin, do you want to add anything before we move on to the next question?
Sure. So we have computer science classes at our school, but they're not really as, I want to say, in depth as I'd like to go. So we have our coding club, and we always work in our brand new makerspace. So usually like a lot of talking about the code because people are like collaborating, but sometimes, as you guys have said, there is quiet moments because everyone's trying to focus.
Well, and if you find that state of flow, there's a great video. It's called Flow Theory in, I think it's like 5 minutes. And it's a really powerful video about how you get in that zone where you're going. And I think that speaks to that quiet space sometimes that you have when everyone is really focused and just really into it, right? You're on that path. And then there are those times when it is more of a collaborative conversation, especially when you're trying to debug and solve a problem and figure out where that mistake may be. And I know our team talked about one of the really powerful experiences coding is that finding mistakes is rewarding, right? I don't think there are too many other situations in life where we would equate making a mistake with being a rewarding experience, but this is an excellent context to explore that conversation and talk about what that might look like in other classes or in other subject areas too. All right, Rylin, do you want to move us on to question number 2?
Of course. So for our second question, coding is about problem solving. Name one problem you see in the world today and describe the steps you could take to solve it.
All right, who'd like to tackle that one?
Here, I can go.
Great.
I say this a lot for the people that know me from Twitter and conferences. The amount of jobs in the coding computer science field is absolutely unreal. So I want to solve that problem by empowering students to get involved in this field by not only giving them the opportunity to code, but going to all these summits and conferences all over the province and maybe soon internationally, who knows, and giving teachers the opportunity to see what coding is and how they can bring it to their students.
Yeah, Steve, do you want to speak to that?
Yeah, I think that's an interesting problem, Austin. There is a lot of talk about all the jobs that are available in computer programming and computer science, and also just that all the jobs will need computer programming and computer science. So I've been working lately with a gentleman who works with the Boston Celtics. And he's like me, had the dream of being in the NBA, but lots of different reasons made that not happen. But what he does is he works for the Boston Celtics, and they analyze where they take shots from. So they have cameras set up in all the arena, and they analyze where all the players take shots. And then they actually write computer programs to go through that information and to find out what are the best things to do on the court, which are the best players that are shooting the best in certain locations on the court. And these computer scientists get to actually speak to the coaches and say, you know, you should play this person more, or you should run this play, or maybe we should trade for this person. And if you're watching the NBA right now, the Boston Celtics are doing very well, a little better than the Raptors, unfortunately. And so a lot of this stuff is really paying off for them. So that's a good example where we don't realize that computer science and computer programming is really influencing the sports that we watch every single night. There are people kind of analyzing all that information. So no matter what field you're interested in, there's problems to be solved in all of those fields. So it's really cool to know if you know how to write computer programs, you kind of have this extra tool to solve problems, which will be really, really important.
Yes, I actually had a really interesting conversation with a group of teachers yesterday who are also farmers, and they were talking about the need for the agricultural industry and the people that work within it to also advance their skill sets in the world of computational thinking and computer programming and computer science, because so much of what happens on a farm now is done by machines and robots. And so the food that we eat now, the way that it's grown, the way that it's harvested, all requires farmers to have a certain level of digital skills. And so it was really interesting to have that conversation too. Anyone else? Aaron, Gustavo, do you have, if you could solve a problem in the world today? You don't have to give us the answer, but what problem would you solve?
Probably like stress, maybe.
Yeah.
Stress would be a good problem because during tests or like really hard exams and stuff like that, people tend to get stressed and do the worst in like stuff. And so in Innovation Club, my group and I, we built this thing which had sense, and we 3D printed the tip of a pencil, which relieves stress using different types of essential oils.
For health, for example, in hospitals, you need prosthetic hands, but we haven't developed much of that. We need more advanced technology, like to actually help people. So there was this machine. So in science and technology, we actually watch problems in the world and see how we can fix them. We reflect on them, and so one of them, it was a disease that caused it disabled you from walking. I forget what that's called, but someone developed a machine that could enable you to walk. It was basically maybe a box you didn't sit in it, but you put your legs in, and it basically walked for you, so you can move. And yeah, so we could develop some more advanced technology once we've gone further in in computing.
Anything's possible, right? We're limited only by our imagination.
Yeah.
Yeah. Stephen, do you want to speak to that?
Yeah, those were two cool examples. They were talking about stress and they were talking about healthcare. I'll give you two quick examples I heard on the radio. One is that the way we use our phones can sometimes show researchers whether we're really happy or if we're really sad. So some researchers are actually recording like the swipes that we do. They get permission from the people, and they find out that when they use their phones maybe a little bit more often, or they use them late at night, or they stopped contacting certain friends, or they use certain apps a little bit less, that it might show that they're actually getting a little bit sad. And so they're finding that they can use like computer programming tools in their phones to kind of get a little bit of a heads up when people are feeling a little bit sad, which is kind of cool. So we could actually have these indicators that tell us when things might be going wrong for people and when they're sad, which is kind of cool. There's another cool example about the healthcare thing, where oftentimes people will need donations for kidneys. And so someone will donate a kidney to somebody else, but maybe they're not a match. So they want to donate to their cousin, but their blood types and different things, those kidneys just don't match. And so what computer algorithms are doing is they're taking in everybody who wants to donate a kidney and everybody who needs to receive a kidney, and they can do like 4 or 5 or 6-way matches. So they use these really cool mathematical concepts where they can figure out who needs to exchange which kidney with who, so that like 5 or 6 people can all kind of exchange a kidney. And that way you might not be giving your kidney to your cousin, but you're giving it to somebody you don't know, but that person's friend is giving their kidney to your cousin who's a match. So they're using like mathematics and things to really like save people's lives, which is pretty cool.
That is amazing. That's absolutely amazing. Wow. There's a Stacy Walwyn, Terrace Bay. She has shared that some of her kids are talking about a recycling robot that picks up recyclables and recycles them without anyone walking around, which is also there's another problem that's being solved by robotics, and that requires someone to design a computer program, right? Behind every machine and every robot is a person doing that work and imagining the possibilities and creating that. Rylan, did you want to add anything?
Lee, I'm actually going to pop in. Hi. In here. I've been listening and following on Twitter, but I had to come in as I listened to everybody talk about the cool things that they could envision for the future, and Stephen talking about all the different ways that coding and algorithms are being used everywhere else. It brought me back to the question before, where people were talking about like the struggles in coding and the debugging and all of those things. So yeah, we see the end product amazingly, but there's all those edit revise stages to get to that final. So the ideas that everybody are coming up with and sharing based on what's going on, there's so much more behind them, even though we might only see the short little code that they use, the amount of information and time people have put into this is huge when they talk about coding and computational thinking and all of those great things that the future holds. So I just had to run in from my class and be like, okay, I need to voice myself because I didn't have enough space on Twitter to share everything. So thanks for letting me pop in for just a second. Rylan is here still, and she will get to the next question. But I'm just loving the discussion here today, and I don't normally get to pop in, so I wanted to say hi and thank you.
Awesome. Well, thanks for joining us.
You're welcome.
Nice to see you. Rylan, do you want to add anything?
Yeah, what she said was pretty good, but
Ditto.
for what we could make to help solve problems is, I saw this thing on Instagram, and it was this little robot, and he just had little stick arms and little ball hands, and it was the cutest thing I'd seen in the world. Like, he was talking a little bit, and it was so cute. And for people who feel alone or have anxiety or something, I feel like we could create like a little friend almost to help people who don't feel as who don't have somebody there with them all the time. They could just have this little friend to talk to and just make them feel comfortable and help them with whatever's going on.
Absolutely. Stephen, do you want to speak to that? I imagine you heard the story on the news the other day, I think, like I did, about a student who's invented a robot to support students with autism. Did you hear that?
Yeah. That's a really cool idea. We were working with a teacher in an elementary school about a year or two ago, and she had said she wanted to do some work with robots, and so we talked about which robot to buy first. And she had bought a Dash and Dot robot, and she started working with the students. And one of the things that she came back to talk to me about, she thought the technology was neat and making the lights go on and off and all that stuff was really cool. But the thing that she liked the most was there was a student with autism who had started speaking to this robot, and the number of words that this student said every day was increasing every day because the student could really relate nicely to this robot. And then they started speaking more to the student, and it really helped the student open up, which is really cool. It reminded me that all of the problems and all of the solutions that we're talking about here, they all have to do with people. So we talk about coding, and we talk about computer programming, and we talk about robotics, and we think, oh, you're alone on a computer and you write code and then you send it out to the world. But that's not really how a lot of these problems are going to be solved. If you're designing a program for, let's say, your 5-year-old little brother and you want him to learn some mathematics or how to read, it's a good idea to involve your 5-year-old little brother in the process. So then he can help you, show you how he likes to press buttons or how he likes to use the program. So the more and more we talk about coding and the more and more we talk about solutions and problems, I think really what we're getting to is we're talking even more about people and about helping people and relating to people and empathizing with people and saying, you know, I don't know what's best for you, so you tell me what's best and I will try to find a solution and we can work together to find that solution. So I think it's really cool when we talk about coding and robotics, but then we blend it with having people kind of right next to us, and we just put it all together. I think that's really cool.
Powerful. And I see Emiliano's just joined us. How are you? I'm not sure how much you've heard or if you're just jumping in cold.
I just jumped in, so I'll listen a bit and then I'll jump in.
You got it. All right. Anyone else want to speak to the second question that that's out in the group? So coding's about problem solving. So is there a problem in the world today? Anything else you want to speak to solving problems in the world today? All right. Why don't we move on to our third question? Rylan, if you want to go ahead.
Yep. So our third question is, why do you think learning to code is important?
And I think we've been touching on that question in the conversation we've just been having. I can give an example that was just shared on Twitter. This is from Stacy Walwyn and the group, the students that she's with today in Terrace Bay. So far north, and so happy you've joined us. They have a community bear watchers app, right? Not something we have to worry about here in our rural community in southwestern Ontario. But they have a community bear watchers app because they have bears in their town, and the app is designed to help keep people safe. So you can take a picture with the app, tag your location, and let people know how to stay safe and how to avoid that kind of incident. So that speaks to, again, a problem and a solution that was designed. And as Stephen was said, that it's about people, right? It's about how we work together to solve a problem, and in this particular case, stay safe. So who would like to answer question 3? Who wants to start us off? Okay, yeah, Aaron, Gustavo, go ahead.
So if you'd want to change the world, you probably, like, the most important skill you have to learn is to code, because, like, for example, reality is based, like, code is based off reality, kind of, because, like, I don't know how to say this, but, like, you have to think a lot before doing something. Like, not often, but if you want to, like, for example, if you want to do a stunt, for example, okay. Like, you'd have to, like, in mathematics, let's just say, you'd have to learn a lot about mathematics if you want to code, because there's a lot of mathematics involved in coding.
So why do you think that's, like, why is that important? Why is coding important?
I think I know what you're getting at there. I've noticed that with computer programming and things, it's all around us. So, like, the technology we use, and we go to the shopping mall, and, like, there's advertisements shown to us, and we go check our email. And so this computer programming and this, like, media, this digital media, it's all around us. So if we learn to code, we learn how to make those things, but we also learn sort of how those things are made. It's like we get to see, like, the back end of all those things. So, for example, when I go to check my email and I notice that there's an advertisement there for running shoes, well, I can think, as a computer programmer, I was on the internet yesterday looking for running shoes. So I think that email company is actually showing me advertisements for running shoes because that's stuff I've done in the past. So I start to learn how some of these companies are maybe getting me to buy stuff or trying to sell me things. Because I'm a computer programmer, I can understand how they've written these programs. Another really cool one is sometimes if we visit different stores and things, and we use, like, a card to kind of save maybe 5% off at that store, well, they're keeping track of all of our purchases, right? And they know what things I buy. So they know suddenly I'll get in the mail, hey, there's a sale on basketball nets, and there's a sale on soccer shoes. And it's like, wow, how do they know what I love? I totally love basketball nets and soccer shoes. I should go to the store. But the person down the street, they didn't get an advertisement for soccer shoes and basketball nets. They got an advertisement maybe for gardening or for flowers or for something different. And so I start to learn that all of these things are kind of, all of the computer programs are being used to maybe make me buy things. Other times they're used for really good things, but sometimes they're made kind of to get my money sometimes. So if I understand how all those things work, then I can just be sort of a little more of a critical thinker, and I can think, why is this happening today? And I think I know why, and I think I know how this program is running.
Okay, I remember now. Communication. So, for example, in wars, spies go out to like, I don't know, on a mission, and they'd have to find, like, because they can't speak, because then someone will hear them and will kill them. They have to do it in a special way, which is obviously technology, right? So to code, like, you need to code to actually, like, to communicate. Like, communication is a big thing about coding, because, for example, like chat, like this chat right now, we're using code to chat all around the world, and everyone is seeing us right now. Like I'm talking right now, and, like, it's being transmitted all over the world from one device, or, like, the internet.
Absolutely. So I think what I hear you saying is that almost everything that we use today it's a form of technology, right? Everything we use, I mean, this is technology, right? Back in the day, believe it or not, this is tech. And as tech evolves, it allows us to communicate in a whole variety of ways. So even your war example, immediately I thought, oh, Morse code, right? That's a form of code. It's a way that we used to communicate. And I believe it evolved out of a need for a different kind of communication in a particular situation. And so like the technology that we're using today, which you just mentioned, this kind of technology, again, was created to address a problem that was identified, which is a need to connect maybe more globally face-to-face, which is not something we were ever able to do. And now here we are today connecting with students across the province, and we have classes from different places watching. And this is everything that all the technology we're using today all of that was written. It's a program written by someone or a team of people, right, in order to make this kind of communication possible. Right, Lynn, you wanted to chat, and then Emiliano.
Yeah, so I was thinking technology is a huge thing now, and it's going to get even bigger than what it is now. And so I kind of feel that we don't need to, but everyone should learn coding some way, because soon learning being able to code, everyone will know it, just like changing a tire. Like it'll almost have to be in an everyday life. Like in a couple 10 years, I go and buy a house. Maybe this, with technology sprouting so high, this house is going to be all entirely just tech. And if I don't know how to code and something goes wrong, then I'm going to have to pay a lot of money for somebody to come in and fix it. But if everybody learns how to do it, then you can just be like, oh, well, it's just a simple thing with this, this, and this, and you just do, and it's done. Like, I feel someday coding is going to be the equivalent of changing a tire. Everybody's going to know how to do it, and everybody's going to just, yeah.
I love that analogy. Steve and I, are you tweeting that out right now? I hope you are. That's awesome. Emiliano.
Okay, so adding a bit onto what Rylan said, I think coding and technology, as she said, is going to be very relevant. It's already very relevant right now, but even in the future, especially in careers, we've seen a lot of statistics that a lot of future careers that we don't even exist right now, are going to be technology or coding focused. So I think it's important for every student to at least have an opportunity to code, so that they can have a bit of exposure to it, so that it can, create an interest in them for coding, because again, it's the future of the jobs. So, yeah.
Yep, agreed. And if we don't understand that foundational language of a computer program, then it forces us into a situation where we have to accept the technology that we use, the way that it's been designed, right? And that might not always work for us. But if we don't have that skill set to think critically, as Stephen was talking about, with regards to what actually happens behind the scenes, and then we're forced into that situation where we do have to use it as is. But it's very empowering to be able to see behind the scenes and think critically about why that program was created, how it was created. And if I was the creator, what would I do differently, right? It's very empowering to know that you have a skill set to then adapt, augment, or modify the kind of tech you're using in a way that's going to work better for you. Austin, did you want to jump in? And I have some things from Twitter here too.
Everything that I wanted to say has already been said. So
summarize for us.
Kind of like, so basically coding is like, to me, summarizing this is that coding is starting to become a bigger and bigger thing, and it's only going to get bigger and bigger and bigger. And honestly, I foresee that eventually it's going to be part of the curriculum, because as Rylan said, everyone's going to know how to code, and everyone will be coding. So I'm hoping eventually it'll be part of our education system.
Oh, I'm sure Stephen has that same hope. Do you want to jump in?
Yeah, we can. I think Austin raises a good point. The thing we have to remember is, like, our curriculum has lots of spots for using tools and using things to solve problems. And so you know, we can wait for different changes in the curriculum, but we can also say, you know what, this thing is a tool. So rather than use these blocks to learn my base 10 numbers, or rather than using scissors and paper and glue to show that I know a lot about this country that I researched, I think teachers are realizing, wait a minute, coding is like a tool. So until we have that curriculum, we can at least use it right now to just have people learn new things, where we like code in order to learn mathematics. Or we can use coding as a way to show what we've already learned. So we can build like interactive posters and things with the makey, or we can write little programs that have little characters moving across the screen to teach us. So yeah, I'm with Austin. We're all waiting for that as well, Austin. But it's cool to see teachers using computer programming and coding as a way to either get students to learn other topics, or as a way to show what they've like already learned, which is really cool.
And we have a comment from Twitter here that from @TeachMrsK's class, that the skills needed to code are ones that can be transferred into many different disciplines, right? Learning how to think critically, solve problems, and those are huge to help grow as the world evolves. And I think that's exactly what the two of you are speaking about today, that even though it's not written in the curriculum that's, you know, thou shalt teach coding, it's the skill sets that are embedded across all curriculum strands that can be taught through the process of coding. And a lot of those skill sets fall under the umbrella of computational thinking. And maybe Stephen, do you want to maybe close on that note? Sort of putting you on the spot here, but what would you like to close with today as we wrap things up? What would you like our students to take away?
I think it's awesome that this many students are interested in this. I think it's because of the cool work that teachers have been doing, and students like Austin, and the students that are in here right now. You're all telling everybody how cool coding is. And so my hope is that you'll go off and you'll actually start teaching others as well. Because we definitely, Austin mentioned it too, we need lots of students doing this. We also need lots of teachers doing this. And so when students learn how to do it, they can actually teach others. So it's really cool when we see like grade 6s learning something, and then they'll go teach the grade 4s. And sometimes we call it teach it forward, where the grade 4s then teach it forward to like the grade 2s. And suddenly in like a year or two, you have your whole school that knows all about it, which is a really cool thing. The other thing I want to remind everybody is, I think we've all touched on it tonight or this morning, just about people. So just about coding and solving problems, and just how much it's about people. So like when we do coding in our classrooms, it's true, sometimes we're just problem solving and we're all on our own, but a lot of times we're saying, hey, what did you do over there? And we're starting to talk more with our classmates, and we're learning how to explain things to each other, and we're sharing ideas. And when that happens, all of our programs get even better, and we start to solve even cooler and cooler programs. So definitely, as you're coding more and more, make sure you do it with people, make sure you do it for people, and you make sure you teach lots of other people as well.
Well said. Thank you. And I want to thank all of our guests on panel for joining us today and contributing to such a rich conversation around this idea of coding, and the whole idea that coding is about people and solving problems and leading with empathy, right? And I love, Stephen, I love that you ended with that idea about teaching it forward. And Austin, I know that's something that you spend a lot of time doing as a student, and Rylin, and I know Aaron and Gustavo and Emiliano, you all lead with that empathy, and I know that you're doing your best to share what you know and support others in all learning. So that is to be commended. So thank you. And I want to thank everybody who joined us on Twitter today and participated in the conversation. And for those of you that will watch this video afterwards and take part in our slow chat for the rest of the month, you can find us on our website at onedstudentchat.com, and you can find us on Twitter at onedstudentchat. This is our last chat for the 2017-2018 school year, but we will be back in October of 2018 to kick things off again. Hopefully lots of our students will be back again, and we will have some new students on panel joining us as well. So we hope to see you then. Thanks, everybody. Bye.